Dr. Deshmukh, can we start?
Yes, sir, you can start now.
Right. Thank you, Dr. Deshmukh.
Hello.
We have a very eminent scientist today with us, Dr. V.A. Bapat. He will be speaking to us on RISE Biotechnology.
Please unmute yourself, Swarnajit Singh, sir.
1 minute. Yeah, I'm unmute, sir. Unmute. Can you hear me? Hello?
Yes, yes.
Yes. Okay.
Yes,
Okay.
sir.
Okay. Today we have a very eminent biotechnologist, Dr. V.A. Bapat, who will speak to us RISE
I think
Biotechnology.
you are not audible.
But
If
sir,
I am correct, you are not audible, sir. Swarnajit Singh, sir.
Dr. Iqbal, can you hear me?
Yes.
Yes,
You are
yes,
not
sir.
audible.
Yeah, but Dr. Deshmukh cannot hear me.
There must be some problem with.
Yes, with the mic.
There is a. But your voice is clear.
Yes. Dr. Deshmukh, can you hear me? Hello, Dr. Deshmukh? No, he cannot hear. So anyway, I hand over the mic to our coordinator of Chandigarh, Shelly. Shelly, please go ahead with the introduction.
Yes, sir. Good evening to one and all present here. First of all, I would like to welcome Dr. Arvind Deshmukh, sir, President of MBSI. His immense passion for microbiology and support he is providing to students in this field is commendable. Secondly, I welcome Dr. Swaranjit Singh, sir, President MBSI Chandigarh Tri-City, Nagaland, Manipur, and Ladakh. Lots of efforts are made by Sir to invite eminent speakers from diverse fields. Sir has been honored by the Stanford University, USA, as the top 2% most influential scientist in the world. He is now concentrating on the mission to save River Ghaggar in Panchkula. Last but not the least, I would like to welcome our guest of honor,
কালকে ডাক্তার রবাবসুকে দেখাবো চোখটা ঠান্ডা লাগছে আজকে 1 ঘন্টাই আছে ও 11টা থেকে 12
at Shivaji University, Kolhapur. Dr. Bapat has distinguished career of 46 years and has made noteworthy contributions in basic, strategic, and applied research, which has resulted in greater insight to conceptual development in plant biotechnology. His remarkable research mainly pertains to somatic embryogenesis, synthetic seeds, and plant regeneration in sandalwood and sugarcane. Sir is also involved actively in the work on transgenic banana for delayed fruit ripening. Currently, Sir is working on the tree fruit tissue culture in vitro rescue of endangered plant and has obtained significant lead on phytoremediation on industrial waste dyes. Moving on to the achievements of Sir, awards and honors, Fellow Indian National Science Academy, New Delhi, 2011. Fellow National Academy of Science, Allahabad, 2003. Fellow Maharashtra Academy of Science, Pune, 2001, with 260 publications, and I must say the list is endless. Today, Sir is with us to speak on the topic Rise by Technology, Trends and Prospects. Sir, I hand over the session.
Okay.
Thank you.
Thank you very much, Dr. Sharma, for a nice introduction. First, I would like to welcome all the participants on this meeting, or you can call it as lecture a talk. I selected this topic. I selected this topic, rice biotechnology, trends and prospects, because rice is a very important staple crop, and all of us we eat rice, I think, practically every day. So this I selected as a topic because I thought that this would be of interest to all scientists, even to the common man also. So rice has several genotypes in our country, maybe more than 100 genotypes. They are cultivated practically in all the states of our country, and you can see here so much variations. White rice we know very well, but beside that, black rice is also there, brown rice is there, and certain variety of rice. They have the pigments also. They are called as they are rich in the anthocyanin pigments. So these are the very elite varieties, and you know that anthocyanin are required for our health benefits. The main byproduct rice, not only for our edible purpose. Rice also has certain byproducts also. You know that paddy is harvested rice, and it goes for the shelter, stoner, dehusker, polish whitener, grader also. Beside that, rice straw, rice husk, ash, broken rice, rice bran, all these are having the byproducts. Some of the byproducts are obtained after rice is harvested. So nothing is goes west from the rice cultivation. Rice also has many health benefits. Rice are rich in vitamins, mainly folate, thiamine, niacin, and vitamin B6, and other minerals also rice contains. Rice is considered as a great source of energy. Rice supposed to prevent the neuro disease, that is Alzheimer's disease. It is excellent source of vitamins and minerals, which already said. It is cholesterol free and helps to reduce the obesity also. It is best for those who suffering from the hypertension, protects against the development of cancerous cells, provides relief from diarrhea and irritable bowel syndrome, and husk of rice effectively treats the dysentery. So diabetic patients should also include brown rice. It's good for them, not meal rice. So rice has several health benefits. If you check the macro and micro elements in rice, you can see here it contains protein, fiber, carbohydrates, total fats, monounsaturated fatty acids, saturated fatty acids, polysaturated fatty acids. So you can see here on the right side, you can see how much vitamin A, vitamin E, calcium, iron, manganese, vitamin K. So the base advantage of rice is it is easy to digest. It is gluten free, and it is the powerhouse of energy. Oil is also extracted from the rice husk. It is called a bran oil, rice bran oil. It also has certain health advantages. Bran oil obtained from rice husks. It reduces the menopause symptoms, promotes a healthy heart, prevents cancer, keeps skin soft, prevents allergies. Good taste, contains good fats, boosts immunity, and helps reduce weight. So now many people are shifting and using the rice bran for cooking. The main topic of my lecture today is the rice biotechnology, and what should be the objectives. And following work has been done in rice as far as biotechnology is concerned. Plant breeding, molecular breeding for higher grain production, a rapid mass multiplication of the hybrid rice varieties, anther culture for haploids, conservation of rice germplasm, transgenic plants for biotic and abiotic resistance, molecular farming for biofortification of rice genotypes, and rice genome sequencing. So these are the prominent objectives which has been pursued throughout the world in the rice biotechnology. The rice has two main species, that is Oryza sativa and Oryza japonica. The rice scientific name is Oryza sativa. It is a edible starchy cereal grain, and the grass, it belongs to the grass family, that is Poaceae. You can see that roughly one half of the world eat rice, that is mainly in the Southeast Asia, and 90% of the world's rice crop is eaten by humans. Rice is cooked by boiling, or it can be grounded into flour. It is also eaten alone or in great variety of soups, side dishes, and main dishes in Assam, Middle East, and many other dishes, many other cuisines. And other products of rice are breakfast cereals, noodles, alcoholic beverages as rice wine, called as Japanese steak. Indica and japonica are the two main species which are widely cultivated in mainly tropical and temperate regions. Japonica rice generally cultivated in the temperate countries, whereas indica rice is cultivated in the tropical countries. So these are the two main species of rice called as indica and japonica. You can see that the differences has been given here. The indica is tall, tillering is very heavy, adapted to the tropical countries, drought tolerant, disease and insect resistant, lodging resistant, low grain to straw ratio, seed dormancy, and lax cold tolerance. Against that, japonica is short. It is tillering is not very good, not very high, and it is adapted to the temperate conditions. It is more prone to the attack by insects, viruses, and pathogens. And there is no seed dormancy in japonica, where indica has a seed dormancy. But japonica is tolerant to cold. That's why it is cultivated in the temperate countries. These are the certain species of rice, well-known species throughout the world, and in our country also. You can see that all these are the main species which are largely cultivated in our country. You can see here Ambamhor, Basmati rice, Champa Dobraj rice, Govind Bhog rice. So these are the local names. These are the local names, and throughout our country, rice has been cultivated. You can see here, this is the little bit 3-year-old figure, but among the world, China is the main country producing the highest rice, followed by our country, then Indonesia, Bangladesh, Vietnam, Thailand, Myanmar. So these are the different countries, but China and India are two major countries which are producing the largest cultivation of rice. You can see that rice is now and the future. Rice is, you can see here, up to the International Rice Congress is held every 4 years, and up to 35% between 2010 and 2030. You can see that the demand for rice will grow up to 25% between 10 and 2030. And climate change would lead to rice price rising more than 30% by 2050. So because of the climatic changes, the rice production will be lowered. So we can see that here, and more than 90% of the rice is farmed in which I already told you that China and our country, and now new types of rice has been developed, because you know that all our crops are subject to the abiotic and biotic species. So we have to raise the plants, not only rice but other plants also, which should be salt tolerant, drought tolerant, flood resistant, and wind resistant. These are the parameters. They reduce the harvest of rice, not only rice but other crops also. You can see here, these are top states in our country. Andhra, Punjab, Tamil Nadu, Bihar, Chhattisgarh, Odisha, Assam, Kerala, and other states. These are the main states, and West Bengal is the highest cultivar of rice. And in Maharashtra also, the rice is considered a second important crop, and is grown over an area of 14.99 lakh hectares with an annual rough rice production of 32.37 lakh tons. So the average productivity of the state is 2.1 ton hectare, and Maharashtra ranks 13th place in the rice in our country. In India, rice called paddy cultivation in 2020 it was 50 tons, so 70 lakh tons rice was produced in 2020. In 2022, rice paddy production for India was 172 million tons. Rice production of India increased from 64.6 million tons to in 1971 to 178 million tons in 2020, growing at an average annual rate of 2.68%. So production of rice has been increased in our country. So rice plant breeding is a very important work, and active work is going on throughout our country and even in the world also. And the better the traits are, what are the traits required and which are being targeted in the rice breeding work are better grain quality, better plant architecture, reduce water, fertilizer, pesticide usage, and sustainability in the diverse habitats. So these are you can see that the lower boxes, the characters have been given. I may not read the entire thing, but the goals of the rice breeding is concentrated mainly on this, that to get a good variety which has these characters. So much work has been done in plant breeding in rice, and so many novel varieties have been developed by the plant breeders. In rice, there is that aromatic rice. Rice has certain varieties which give the very pleasant aromas. When you cook the rice, the aroma will come and we can enjoy the food. So people want aromatic rice, and this rice has definite aroma, flavor, and taste. These aromatic rices are generally of medium to long range varieties of rice, having variable aromas and flavors, sometimes with a toasty nutty fragrance. All of you know that Basmati aromatic rice is very famous, and it is in great demand, and it is consumed not only in India and throughout the world. In America, it is sold as Texamati. That is, they did some hybrid work and they changed the name from Basmati to Texamati. So because it is a very great demand. These are the certain pictures of the traditional aromatic rice cultivars and their derivatives. You can see here so many cultivars, they have got capacity to produce aromas, and these are called as aromatic rice. What are the factors? Aroma is a very important factor, and it is pursued in the biotechnology. But the aroma is controlled by so many factors. It is first controlled by the genetic factors. It also controlled by the harvesting times. Then the two acetyl one pyrroline is a chemical which makes the aroma. So this depends on the planting density and harvesting time also. When you cook, it is very important. When you cook, the fragrance will come up, aroma will come up, and it requires certain methods for roasting and paraboiling and milling. These are the things which on which the aroma quality is controlled. These are the factors which mainly control this aroma quality. As far as chemistry is concerned, you can see here the rice plants. This is paddy and the rice milled rice, final product. And this two acetol one pyrroline is a compound is the key compound which gives to aroma to the rice grain. You can see here the chemistry of the aromatic rice. Why this is the normal pathway. This is putrescine, glycine, and when the gene is getting this is non-functional gene. The functional because of the mutations, it becomes non-functional, and this the pathway gets changed. Pathway gets changed, and you can see the aromatic rice here. So this is the main pathway, and once this non-functional BAD gene becomes non-functional, it turns to the aromatic pathway, and we can get aroma in rice. There are certain methods have been done to purify these compounds, and all the water compounds from the rice aroma have been obtained. They are used by using the modern water instruments, and you can see here these are 12 main varieties of rice which are very widely known as aromatic rice, and these are the compounds. These are the main compounds which give to the aroma to the rice. So this is you can see here this rice. What are the other factors? What are the other factors that food processing industry, nutrient content, biofortification via bioavailable zinc and iron, beverages industry via bioaroma and bioflavor. So rice aroma is also used. These are applications of rice aroma, not only as a staple food, but also for getting the beverage industry and other flavors. Now, to improve the rice, mutation studies have been done in rice. Extensive work has been done in rice mutations. And rice mutation have been done by using the gamma rays or chemical mutagenesis. And rice mutant varieties have been released throughout the world, mainly in China, Japan, in our country also. And these are the other countries. Rice mutants have been released, and they have been cultivated throughout the world. So what exactly the goals of the mutations is? Basically, mutation work has been done mainly in the aromatic rice compared to non aromatic rice. So what are the goals? What are the targets? To induce the mutations which would have early maturity, low logging, increase in of aroma, tolerance to abiotic species, sustaining different soil types and environments, high quality of grains, suitability for milling, cooking, and delicious taste, high pressures or high presence of nutrients, and finally it should be accepted by the consumers. These are the characters, although they are written here aromatic rices, but these are the goals of even mutations in rice, non-aromatic or aromatic rice. In our university, Department of Botany, they have worked on the mutation breeding in rice, because we have here in our Kolhapur district two aromatic rice varieties. They are Adra Ghansal and Kalajiri. And this work, induced work started in 2016, around 7 years back. We got a project from BRS project and started a work on two indigenous local varieties, Adra Ghansal and Kalajirga, and they are aromatic rices as good as the basmati rice. So this is the Adra Ghansal rice in Kolhapur district. It is accepted by the consumers. Kala Jirga rice. This is also a very favorable rice which consumer want. But what happens here? These are both the varieties are cultivated in a very narrow landscape, that is in Adra Taluka. Adra Taluka in Kolhapur district, the farmers are generally cultivated these two type of rices, who are they are having good aroma taste as good as the basmati rice. So mutation studies were done in both these varieties, Adra Ghansal and this one. Basic studies have been done by using all these other techniques, and 6 generations have been done in the field. 6 generations have been done in the field. What we can do here, we see here this was mutagenesis were given to seeds, M1 plants are cultivated, M2 seeds were collected, again replanted next year. So this cycle was continued for 6 years, and at the last year, finally the mutants were separated, and these mutants were then put for the official release. You can see here, these are the varieties obtained by our scientists in university: dwarf mutants, lodging resistant mutants, high yielding mutants, early maturity mutants, and more killers. And these we cultivated in our department and in the Agra Taluka. Our mutants were tested for 6 years. 6 years were tested. They were stability was confirmed. And last year, we were given the seed material to Mahatma Phule Krishi Vidyapit, and now this year they're conducting the state level trials. And we are expected to get the data in another month. And once we get satisfied data, this will be declared at a state level variety, and then it will go to the national level trials, and finally is the final variety. So these are the main goals which the main characters which you obtain in our mutants: dark mutants, lodging resistant mutants, high yielding mutants, and early maturity mutants, and more killers. So if it comes, it is we think that it will be a very good contribution from our university, because we are non-agricultural university. But even if the variety is released, it will be a good contribution of our university. Other people also work, and these are the different variants. These are the different variants. Samba Masuri rice. You can see here by giving the mutations, all the variants are not good. So we select the good ones, and cultivate further for further generations. Now in the rice, rice is a very important, is a versatile plant as far as tissue culture is concerned. And rice has been cultivated, rice has been cultured from seed callus. Seed callus is raised, then the seed callus regenerated somatic embryos. Somatic embryos were then transferred and plants were obtained. So this is the rice, basically rice agriculture. Extensive work has been done, and so many varieties have been cultured, and successful protocol has been established in many rice varieties to regenerate the plants from the cells from the rice seed callus. And this is mainly useful for transgenic studies, as well as to release the hybrid rice in it as far as possible. So these basic steps in the rice seed or embryos culture: callus injection, the multiplication of the callus, regeneration, plantlet or obtained, plants are hardened, and then put it in the greenhouse, and finally from greenhouse to the outside field. So this is the basic steps required for the rice regeneration using the tissue culture technology. You can see here rice, how it looks in the plant tissue culture. This is also used for the conservation of germplasm also. Plant tissue culture is used mainly for the conservation of very precious germplasm by these methods. Another very important work has been done in the rice, that is called as anther culture. We know that haploids are very important for the plant breeding work. And in the normal way, it takes 10 to 12 years to get haploids. But by using the in vitro anther culture, one can get the haploids in very short time, within 6 months. And there are many cases where rice anther cultures have been used for the plant breeding work, and these are integrated in the plant breeding program. So rice anther culture has been done. Rice anther culture has been done. Anthers were obtained from rice plants. They were cultivated on the medium. It forms a callus, and then the regeneration of plants. Then the chromosomes were tested, and these haploid plants are then make the double haploid to get the pure lines. And these pure lines then crossbreed with other varieties to get the more varieties which will have the homogeneous gene sequencing. You can see here rice, another picture, how the rice anthers are cultured, callus regeneration, and they planted in the field. So there are so many reports, and many the work has been done in China, and so many rice varieties have been obtained by using the agriculture technology that is called as androgenesis. Rice is also subjected to biotic and abiotic stresses. Uh, so major disease in rice is blast, bacterial leaf blight, rice tomato disease, sheath rot, top of smut, grain discoloration, and other things, lipstick. So these are the major drawbacks. You can see here, these are the enemies of rice, and because of this biotic stresses, insect and pathogens and virus and fungi and bacteria, rice production goes down. So these one has to now develop the new technology, especially biotechnology, to get the rice which could tolerate these attacks of the pathogens. You can see here the rice is drastically affected by viruses, bacteria, and fungi. You can see here so many things are there. So we have to develop the new clones or new varieties which will tolerate the attacks of these pathogens. So what are the steps? What are the steps to improve the uh, to improve the disease resistance in rice is large collection of germplasm. We have to collect the rice as far as possible from so many places. Collection has to be made. From that, selection has to be done. Then one has to use the high efficiency mapping by sequencing the strategies can be used for a rapid discovery of the new resistant genes. So the resistant genes has to be screened, has to be screened from the large collections which are available, and these resistant genes can be directly incorporated by either by market edge selection, genome selection, or transformation approach. So these are the three. When the R genes are obtained, they can be put it in the rice plants by these methods: MAS, GS, and transgenic approach. And the new technology that I will talk in my after some slides is called as CRISPR technology. That has been used to make the rice tolerant to the pathogen attack. So you can see here you can see here the germplasm first collected. This is natural nursery. Then screen here in the greenhouse, and the prominent plants were they separated, and they do this molecular work, and they identified the discovery of the orchids by doing the so many molecular biological technologies. High accuracy discovery R genes are obtained, that is resistant genes are obtained, and these are then called as BSR genes. These are then used by using genome editing. The right genes are separated, and they are put it in the by using the MAS or GS. They put it in the plant breeding programs, and this can lead to the rice varieties which are resistant to the pathogen attacks. Like biotech stress, rice is also subjected to abiotic stresses, mainly drought, salinity, cold, heat, UV, and heavy metal. These are the major abiotic stresses. They are causing the damage to rice cultivation. So, what are the different very simple ways is to avoid these things? Escape from these abiotic stresses, recovery as far as possible, recover the product, and then find tolerance. So these are the different strategies. They are used in the abiotic stresses, which are mainly cold, heat, and global warming, submerged and flooding. What happens during the floods? Many of our cultivated lands are going underwater, and they affect the production. Drought is another very serious abiotic stress. Soil salinity and the nutrient stress, because in sometimes the soil is not very fertile, it lacks the key minerals, and because of that rice production is suffered. So these to counter this work has been done, as I said in our last slide. Tolerance rate are raised, then QTL quality trace loci were identified, markers were obtained, genes were isolated, And these are the stress management studies. And finally, biochemical studies were done, nutrient phytohormones, and these are common studies done to obtain the tolerance size to the abiotic stresses. Rice germplasm is very important. You know that rice, any plant, any precious plant has to be conserved. Otherwise, after some years, that germ will be lost. So, rice germplasm has been conquered by the following methods. First, get the rice material, conserve in either active or working collections, then multiplication by using plant agricultural method, then has to be characterized, plant genetic resource utilization, breeding biotechnology, biological diversity management, and finally the new products, new varieties, crops, pure applied research on farm diversity. So first, very important thing is the collection of the material, conserve it by different technologies, then multiply the good clones and characterize the clones, make the documentation also, and finally the distribution. And this is followed by biotechnology, biological diversity management, and using products. You can see here in the International Rice Center in the Philippines, rice genotypes has been conserved under special conditions. In ICR, NVPDR, around 1,15,000 rice cultivars, rice germplasm has been conserved under the proper conditions. You can see here, these are how they collect the rice. The kind of rice sowing is done, and then finally seed, it has to be, documentation is very important. Rice cultivar has to be documented, herbarium has to be made, and these are the things then conserved in the system. However, there are certain simple technology also which are done by the farmers, and many farmers have simple methods to store the rice storage which they require for next products. Sometimes the methods are 100% effective. One lady from Maharashtra in Nagar district, she has conserved a simple method more than 100 rice varieties, and because of that she was awarded the uh, Padma Shri Award about 3 years back. Her name is Mrs. Pawar. Simple technology is from a remote village. She collected rice varieties from the wild lands, wild places, and conserved by simple technologies the very precious rice germplasm. Moving on to the another topic, that is transgenic rice, the genetic engineering of plants. Has been, all of you know that the transgenic plants, that is GMO crops, they're very common, and rice has been modified by using transgenic technologies with the goals of to have the rice plants tolerant to bacteria, herbicide, viral. They are more C4 photosynthesis. They are resistant to the allergy, pest resistant, production of recombinant proteins, nutritional value, salinity, drought, and cold tolerance. So these are the goals. These are the main goals which have been tried in transgenic rice, and so many successes are there. And transgenic rice is a new technology. However, the transgenic technology, the major thing is it's called as the target the seed, because seed we eat. So main thing is rice is the, which is called as very popular name, called as the designer rice seed material. It has the higher nutrients of the iron, zinc, selenium, calcium, iodine, low glycemic index, minimum multiple heavy metal contamination risk, high carbon content, vitamin B8, vitamin B12, vitamin D content, increased amount of the fatty acids, and higher amount of amino acids like lysine, tryptophan, and methionine. So this is the ideal, because all the work targeted to obtain and make this rice which has this Kijana rice, means the rice which will have all these characters. It's called as popularly called as Kijana rice. So certain heat tolerant rice plants have been obtained by transgenic methods, and these you can see here. These are the in abiotic stress heat tolerant. So transgenic plants have been raised, which can tolerate the higher heat also at the age of at 45 degrees centigrade. Studies have been done, and these have shown that two genes from the adoblasis were cloned and expressed in transgenic rice to reduce heat tolerance. In transgenic technologies, we can put any gene from any source. So here they put these genes from this plant and put it in rice, which can tolerate to the heat tolerance. You can see here as engineer rice, which has a higher synthesis of transgenic plants have been obtained, which have the higher photosynthetic capacity. They are more green, larger, and show increased photosynthetic capacity, and they have the productivity under field conditions in bright light. So these the key enzyme in the photosynthesis is the one biophosphate carbohydrate. So these enzymes, this gene for the enzymes was cloned and put it in transgenic rice plants, which are showing the highest growth and better photosynthetic capacity compared to the non-transgenic plants. These are the other things you can see here. Different work has been done and studied different what happens the different changes, physiological changes, biochemical changes, molecular changes, and other organizational changes. And you can see here the gene. These are the genes. These are the genes. These are the genes are cloned. They are obtained from different sources. You can see here sources have been given here. Even from the bacteria also they got one gene from apple and E. coli, Plantigo. So these genes are cloned, then put it in the by transgenic technology. These genes are cloned and put it in the rice plants, and work has been obtained, and so successes have been obtained. In our own country, scientists have developed a transgenic rice with reduced arsenic accumulation. So what they have done, they have cloned the gene from this gene. They cloned arsenal methylate gene was cloned from soil fungus, and this gene was cloned by using with agrobacterium. This gene was put it in rice, and this rice can be treated with arsenic. So compared or made between transgenic and non-transgenic rice, so that transgenic plants accumulates less arsenic in the roots as well as shoot as compared to non-transgenic plant rice. This work has been done in our country. Another very important thing is in rice biotechnology is the rice biofortification. Biofortification means you have to provide the rice with certain nutrients, which would help to have more energy, proper growth and development of regulation of metabolism, energy production, boosting the immune system, proper body functioning, ensure optimal health and prevention and fight against diseases. So these are the different ways. Biofortification means to supply the rice with the minerals, vitamins, amino acids, and other things, and to improve its nutritional value. And these are the different ways. Simple is the conventional operating, genome engineering, and genome editing. These are things using the CRISPR technology. This method, rice plants has been put and make it more healthy. So what exactly is the biofortified rice? Fortification is the practice of deliberately enhancing the essential nutrients, vitamins, minerals, and to make the rice more healthy, and could be a complete source of all the nutrients. The fortification factory does not last for more than 45 days, so it is advisable to store fortified rice for long. And According to our National Family Health Survey, 78% children and 75% in the district are anemic and suffer from malnutrition. In the first phase, portable rice will be given to the different mandals, and it will be tested afterwards. It is a process to make the bioportable rice. Rice flour is mixed with the vitamins and minerals from the other sources. Then they put it in certain machines and they make the rice meal or rice is regular rice and comes out in the portable rice. It's mixed here, and this mixture comes out and it is given as a considered as a bioportable rice. The most famous, I think, all of you must be knowing that what is golden rice. Golden rice, you can see here, left side is the normal rice and the right side is the golden rice. It is called as golden. It looks like gold color. So the major facts of golden rice are rice that has been transgenic rice have been obtained. They synthesize the more carotenoids. The most important is beta carotene, also known as provitamin A. The human body can change provitamin to vitamin A. Normal rice does not produce carotenoids in the endosperm because it does not perform the photosynthesis. So generally, what we eat is the tissue called as endosperm. To make the rice produce carotenoid, two genes have been introduced in the rice genome: phyton synthase and phyton desaturase. The more golden rice, the more beta carotene the rice produces. This is the main goal because it contains the two. It contains phyton synthase and phyton desaturase. These are the two genes. Put it in the transgenic plants. You can see here the work is done this way. Two genes, one gene obtained from bacteria and two genes obtained from the plant daffodil. These are put it in the plasmid, and they using the agrobacterium system, transgenic plants were obtained. And these are the rice you can see here. This is the golden rice seed. You can see this transgenic rice has been obtained, which contains the three genes, one from bacteria, two from plants, and they work in this sequence, and they produce the provitamins, which is the precursor for the vitamin A. So the genes is that given golden rice is able to make the beta carotene. I will not read it again, or they put it in the picture. So no need to read again what happens to make the golden rice.
Hello, sir.
Hello.
Hello. You can please wind up in 3-4 minutes.
Oh, sir, I got so many slides now.
Okay. So
another 20 minutes. Okay.
We can arrange one more for you. One more invited talk.
No, but then the sequence will be lost. No, that's why.
Okay, you please take 5 minutes.
Okay. No, I will go very fast. I will not go fast. This is the famous picture of Professor Potricus. He has made the golden rice. This is the sequence has been given here. Since time is limited, I will go very fast. These are how they look, the golden rice seeds, how they look, and different way you can see here. These are current status of golden rice cultivation. Rice has been obtained given the biosafety rules and is cultivated currently in the Philippines, and they are given to the farmers. And I'm sure that within a couple of years, golden rice will be cultivated throughout the world because all the studies have been done. Another thing done in rice is the rice is a gene, that is ferritin gene, to enhance the iron content in rice. So using transgenic technologies, rice has been enriched, which contains a higher level of iron, and this gene is obtained from soybean. How do you know that soybean is rich in the iron? Gene obtained, cloned in the plasmid, and transgenic rice have been obtained which contain the higher level of iron. Like that, rice, so much work has been done, and rice has been enriched with iron, protein, zinc, enhancers, vitamin A, vitamin B, vitamin A, all that I told you. So these are the famous work done, and rice has been involved. Now, metabolic engineering work has been done in rice, and you can see that a gene has been obtained from the vanilla plant, the gene cloned and put it in a rhizogenic plant. So the plant obtained has the flavor of the vanilla gene obtained from the orchid, that is vanilla orchid. So like that, there's so much work is there in the metabolic engineering of rice, and they given a different sequence. You can see that molecular farming, that is to make the therapeutic proteins, vaccines, antibodies in the plant sources. They are called as plant edible vaccines. So rice has been made, and so much work has been done. And these are certain pharma products, therapeutic proteins, vaccines, antibodies, enzymes have been made in rice by using the transgenic technologies. And you can see here, these are pictures here. You can see this one. Now, a rice vaccine has been done. That is the rice you can see here. A rice vaccine has been done against the cholera. These are the transgenic rice, and gene has been obtained and from the sources, put in a transgenic way, and you can see here it has been used, and the microbials has been used to make the micro. Another very advanced technology is CRISPR. I may not go much details because of the time constraint. CRISPR technology, gene editing has been used in rice by using different technologies, cutting the rice genome. Transgenic plants using the CRISPR technology has been obtained containing the genes which we require for the rice. Another picture you can see here how it is done by using the rice work. And these are the certain things that rice CRISPR technology now has been used to fight both biotic and abiotic species against so many stress conditions, and successful work has been done by using the gene editing. Rice work has been used in the nanotechnology also. You can see here, not go much detail here. Nano capsules have been used to get the healthy rice plants by using the different technologies obtained in the nice nano technology. You can see here. The new rice has been called as supercharged rice. This is a new work in China, and they claim that they obtained the genes from the rice only, and has boosted the yields by up to 40%. And this is the called as super rice, and you can large harvest is obtained by using the transgenic technologies. Super rice has been produced in China. Rice is the, now this will go very fast. Rice is the first genome. Rice is the first genome which has been completely sequenced. Has been the first genome of a crop plant that was completely sequenced. Among all the crops, rice was the first plant where complete genome has been sequenced. Rice has a simple, I can say, just see the slide here. Since time constraint, I'm not going much detail. You can see the rice has number of base pairs compared to the other plants. You can see 400 million base pairs the base rice has. And these are the different ways. You can see the rice genome is about 3.8 MB has been sequenced completely. The rice genome has you can see here 70. Okay. What is the application of this genome plant genome sequencing? That we can have specific markers we can use for the rice breeding work, and we can understand how a plant responds to that stresses, and which genes control the various functions of plants that can be followed by using the sequencing method. It can also use to enhance the nutritional value, enhance crop yield by improving the seed quality, resistant to pest, resistant plant hardness. So you can this technology, and the rice genome holds fundamental information in its biological power, including physiology, development, genetics, and molecular biology. Another little bit very interesting work. Rice water has been used. Rice water has been used as an anti. Has been Rice water has been used. It has been studied, and they showed that rice water has certain characters which are called as anti-aging characters. So, rice water has been completely chemical synthesis has been done, and from that they make the commercial products, skincare products using the rice water. You can see that it's skincare products obtained from rice cells. These are anti-aging and face cream with red rice. So these are the certain products that are coming in the market using the rice cells and plant agriculture. Rice aroma can also be cultivated in the culture. You can see that when the cells are cultured, even rice cells also synthesize the aroma. So these aromas can be, these cells can be dried, and the dried cells can be dried mass can be put it in the non aromatic rice to give a flavor. This is the novel work done in many labs. Anthocyanin rice is very important, and they have harvested, widely used in cosmetic products, spoiling monitor, natural dye hair. So pigmented rice also has been used in the many industries. Now rice has also a serum in Thailand. Rice is used to make the rice stem serum, and it is used in the aging processes. So this work has been done by using simple rice. And since this is a microbiological forum, I thought that I should include this slide. Bacteria are very important for rice, which are microorganisms, improve antioxidant capacity, change heavy metal transport, microbial absorption, growth promoting mechanisms, change the physical and chemical properties of soil and microbial communities, interaction between root exudates and microbes in the soil. So rice microbes are also very important for the rice improvement. Finally, this is last slide. You can see that this is the work coming of DNA, RNA, proteomics, metabolomics, and phenotypes. These are the work. So much work has been done, and rice is a very important crop. Many labs are active in working on rice biotechnology. Finally, I wish to thank all the scientists and other sources who uploaded their work on the net, which helped me to prepare my PowerPoint presentation. I'm grateful. I also thank the Professor Singh and Professor Deshmukh for giving me a chance to talk to you. I thought you have appreciated my talk, and thank you very much for your patience listening, and see you again. And because of short of time, I could not speak well with so many slides. Thank you very much again.
Thank you very much, sir.
Yeah.
It was a really excellent talk. We enjoyed every bit of it. And rice has got a lot of potential, like you said, in skincare and so on. So rice is having a lot of potential. You know, in USA, they actually patented our basmati. Our basmati rice was patented by USA.
Yeah, that got taxonomy.
In 1977.
Yeah.
Then India filed a case. And in 2011, you know, we got the patent back. But the trademark remained with them. Trademark was with them. The rice lines remained with them, but India won the case. So rice is a very important component for a country. Now I request Dr. Deshmukh to please comment. We are lucky to have him today. Dr. Deshmukh, I think he has left. Anyway, Dr. Prakash, please ask something.
Good evening, sir.
Yeah, good evening.
Very much impressive lecture. From a CFTRI perspective, only one clarification. Synthetic rice or plastic rice? What are their relevance in today's market? Synthetic rice. We talk synthetic rice.
There are so many synthetic things in our country or in our market.
Mm-hmm.
But generally, consumer want only the natural sources.
Yes, sir.
So the natural sources are far better. Even if we take the simple edible colors, nobody wants artificial colors in the food items. They want natural colors. And I think it is just fancy only to buy the synthetic rice.
What about the plastic rice, sir?
So these are the fancy work done by many people.
Uh-huh.
And plastic wise, I think it's not good for our health, no?
Yeah, that is what actually. So
Nature is number one. Nature is best. Whatever nature gives us, that we should eat.
Other two small clarification. One is related to whether transgenic rice is available commercially now.
Not in our country. Our country it has been raised, but they are in the labs only because biosafety rules are very strict in them.
Exactly. And another thing,
biosafety rules are very difficult to cross. In our country, only the BT cotton gene has been approved.
mm-hmm.
And although our scientists have worked on so many transgenic plants,
Yes,
they
sir.
are in their glass houses. They have now been permitted by Government of India to have the field testing.
Yes, sir. Yes, sir.
But now through many illegal means, they are imported from outside and cultivated.
One small, one more clarification was this low GI rice which you were telling. Is
Which
it done?
one? Which one?
Low GI.
Huh.
Because rice supposed to be the with high GI, what we have commercially available.
No, not all varieties, sir. Not all varieties. See, rice has so many varieties.
Okay.
So the nutrient content is not same in all the rice varieties. It varies.
Low GI rice, which you told, is it developed by any mutation or by breeding practices, or this rice you have selected based on the natural selection? That is what I.
Right. No. Generally, first is natural selection,
Exactly.
followed by selection. Okay. And then the plant breeders we pick up the elite varieties, cross them, and try to get the good characters. That is the normal work. But by mutation studies or by transgenic methods, we
Yes,
can
sir.
improve the quality.
Wonderful. Thank you. Thank you very much.
Thank you very much.
Low GI you mentioned, no? That is brown
Yeah.
rice. Brown rice.
So, thank you.
Okay, thank you very much, sir. And due to time constraint, I request Shelly Sharma to say the word of thanks.
Yes, sir. So before that, I would just like to confirm from sir. Sir, like brown rice, is it actually helping the diabetic patients?
No, it is compared to the white rice. Brown rice supposed to be better for diabetic patients. And there is black. You know that black rice also the black rice.
Yes, sir.
In Madhya Pradesh, many people are eating the black rice also. It's supposed to be the good for the diabetic patient.
Actually, all of a sudden, brown rice has come into so much of demand. So
yeah. Even brown rice poha we make from the brown rice also. Brown poha.
Yes, sir. Yes, sir.
And it is not available. Hello.
Bapat sir, I have some question.
Yeah.
Brown rice is difficult for digestion. I heard this. Is it true, sir?
That depends on the individual. No, digestive system is not same for all the individuals. Okay.
Okay.
And one has to see how one should not eat too much also, na?
Yeah, no, sir. It requires some time to cook. It requires more time.
So
More time than.
What I suggest, instead of eating the brown rice, you can eat the brown poha from rice.
Yeah.
Poha normally are easy to digest. Yeah.
Yes. As compared to white rice, it requires more time to cook. So it is difficult to digest.
That is okay. But suppose if you find rice poha, brown rice poha are now in the market, from that you can make a very tasty rice dish. Poha rice dish.
Okay, sir. Okay. Thank you, sir. Thank you.
Thank you.
Fine. In the last, I would like to express my deep sense of gratitude towards respected B.A. Bapat sir for sparing his valuable time with us and for providing us the detailed information about rice technology, which will eventually be very helpful for all of us. Thank you so much, sir, for your
Thank you very
valuable
much.
time.
Thanks a lot.
I also thank Dr. Swaranjit Singh, sir, for organizing such talks, which are really very helpful for all of us. Thank you so much, sir. And thank you to one and all present here for sparing your valuable time as well. Thank you, sir.
Thank you. Thank you very much. Thank you.
Thank you very much, Shelly Sharma, for conducting the talk. You gave a wonderful introduction, followed by a very good vote of thanks. Thank you, Shelly.
Thank you, sir.